And now we can go straight into the first talk, which is going to be FlowerTune, a cross-domain benchmark for federated fine-tuning of large language models, which is an effort, community-wide effort, but that has been led by Yan Gao from Flower Labs. So Yan, the floor is yours.
Okay, thanks, Javier. So let me share my screen. Yeah, so hello everyone. So I'm Yan, research scientist at Flower Labs. Yeah, so as Javier introduced, today I'm going to talk about the uh, old but new story, FlowerTune. So it's a cross-domain benchmark for LM federated fine-tuning. Yeah, so as we all know, the LM got remarkable performance on different domains and tasks. And to get better performance, what we have to do is to fine-tune the LM on a specific domain-specific data. But some research has shown that we are running out the high-quality public data set. And on the other hand, the demand for the specific or the specialized LM is increasing. So, for example, the domain like the medical and finance. And in these domains, the data that we can't get access to because it's under some regulation of privacy protection. So to achieve this issue and boost the performance of LM fine-tuning, the potential solution is let's do federated LM fine-tuning. So that's why FlowerTune exists. So here's a storyline that I want to walk you through today. So let's start with a template. That means we build up usable templates. It's called FlowerTune, and people can use that for any like a federated element fine-tuning tasks. And build on top of that, we launched the FlowerTune LM leaderboard, so which have various baselines. People can test with different methods to boost the performance. And after that, on the top of the results we got from the leaderboard, we have a benchmark capability to have a benchmark in a unified setting to say so how the different model performed in FL settings. So the momentum to push these things moving forward is come from the Flower community. So now you may let's start from the first part. So you may already hear about FlowerTune tools, but let me just briefly remind you what it is. So FlowerTune is a bundle of techniques to make the federated element fine-tuning easy. So it includes like the Flower data sets to produce and partition the data, and also it has an easy pre-trained LM adaptation. That means you can take any out-of-box pre-trained model and do the fine-tuning. And we also apply like the path technique for faster training. For example, LoRa is could be used in this process. Apart from that, we also apply like quantization techniques for further speed up. And for the final thing is the Flower simulation engine or runtime. So that could be used to simulate the LM fine-tuning, but of course you can do that on a real distribution settings without changing the code. So all come together that make the federated element fine-tuning can be done with just a single GPU. With these tools, we just put the things together into a template, and you can just easily use that template by running this single command. It's flower new and pass the parameter framework equal to flower2. All right, so built on top of this usable FlowerTune template, we launched the FlowerTune LM leaderboard at the end of last year, aiming to like establish like various baselines for different domains that people can easily follow. So it includes four domains. So it's a general LP, a finance, medical, and coding. And at the first stage, you can run LM fine-tuning, federated fine-tuning on different domains. After that, at the second the stage, we provide the corresponding evaluation tools to uh, uh, evaluate the fine-tuning model and give a score to see how good the model is. So yeah, so it's a community effort as we mentioned, and so far in the Slack FlowTune LM leaderboards channel we have 95 people, and people was quite active by asking questions, exchange ideas, and also running the different methods to do the LM fine tunings. And after launch, so we already got many submissions and tested with like different base models. So as we show here, including some popular model like Gamma, Llama, and also DeepSeek. Yeah, so that's what we have achieved. So in the current status of the LM leaderboard, we have got boosted performance for all domains and tasks. So that's two highlights. For example, in the general LP task, we have 5.6 times increase in terms of the evaluation performance. And the second one will be the finance. If you see the finance task, we got around 100 communication cost decrease in this task. All right, so we build on top of the LM leaderboards. So we have various uh, uh, results for different models already. So now it's time to have a benchmark to say, I mean, in a unified setting to see how the model performs in a federated setting. So that's something that no people did before, but it's quite important for the federated LM fine-tuning domain because people so in the different settings, people need to choose the proper model for to do the specific task. So that's why we want to do this benchmark. And there's some highlights. So it's the first kind of first of its kind benchmark to do the 26 LM, the pre-trained LMs on four domains, and we have the various evaluation benchmark, evaluation metrics and the data sets. So thanks to the capability from the leaderboard. Yeah, so in terms of the FL settings, so we have a unified setting for all models, try to fairly compare the performance of them. So here, for example, we use the LoRa or Dura methods for the local fine tuning, and after that, we only transmit the LoRa layers to the server, and then we aggregate them on the server and send that back to the clients and check the next round of FL training. So now let's see some results. So here we showed the average training loss over FL rounds on the four challenges. So you can see that so we have six selected model here. If you check, for example, the general LP task, you can see yeah, so the training loss going down is good, but also the high, so you see the model here with different model size. So if you see this the general LP task, it could be the higher sorry, the larger model would have the lower loss as expected because the larger model would have a higher capability to learn things. But at the same time, if you see the finance task, um, it seems that the model didn't show like much difference in terms of the training loss. The one reason for that is for the finance data, so the finance task we only do the classification task will be easier for the smaller model will be enough sufficient to for this task. Uh, and as for the evaluation metrics, so here we choose the three metrics apart from the downstream task. Uh, and in the downstream task, we use zero-shot settings. That means we fine-tune the model in federated setting and just take the trained model doing the inference on the downstream data set directly. So that will be challenging, but also fair to say that the model performance directly. And apart from the downstream tasks, we also have two systematic metrics, which are the communication cost and the memory consumption. So we think it is also important to show that because in FL setting, some scenario environments will be resource constrained. So that means maybe not everyone could afford the large model, and also for the different domains, the model would shows different behaviors. So that's why we have the multiple metrics here. So now let's just pick one of the domain to show the experimental results, how the model works. So here, the table shows the models in the finance domain, the finance challenge. Um, Here we in the different lines show the different base models, and the columns here shows the performance, the accuracy on different downstream data sets, and it also shows the communication cost and the memory cost in the last two columns. So there's some highlights here. So first, if you see this, the first two models, which are the largest model, it has the highest the accuracy as expected. But on the other hand, the communication cost and memory cost are also high. And another interesting finding is that if you see the smaller model, the small LM, we see that it actually gets some acceptable performance um, compared to some it's for example some larger model. This so as I just briefly mentioned, it's probably because in the finance challenge we only do some classification task, and the smaller model would have the ability for that. So this is good. We can use a small model for this task. And you see in the small model, we have the very low communication and memory cost. Yeah, so you may already found that there's a trade-off between the accuracy, the performance, and the metrics. So here we have a figure to show this trade-off. So this figure shows the same task, the finance challenge, but we just split into the two sub-figures, which are the communication and the memory. And yeah, you see that, for example, this point is for the Gamma 9B model. It's get a good performance, but also still it has the higher, the systematic performance. On the other hand, for example, this blue lines and points here show the smaller model. It has a lower performance, but also yeah, lower the communication cost and memory cost. Yeah, so we just in this talk, we just want to showcase some uh, examples of the experiments, but there's indeed more interesting results in the paper. So yeah, please go to the paper to check more details about this. Okay, so FlowerTune LM leaderboard is still open, so we open for more submissions. And also at the same time, we want to have like more scenarios and more modalities, and we also target to have a more realistic FL settings. So if you are interested in joining this initiative, so please scan this code to join the Flower Slack channel and jump to the FlowerTune LM leaderboards yeah, channels. And also, if you want to check out the more details about the paper, so here's the paper link. Okay, so that's it for today's talk. I want to take a chance to thank so every contributor in this Flower Turing paper coming from Flower Labs and Flower community. Thank you.
Thank you, Jan. I think it was super interesting presentation. I also echo the thanks to the big community that has been making this possible. Thanks to, I think I was counting now, like around 80 submissions that made it to the leaderboard. That's quite something, especially that federated learning still has so much to grow as a concept in AI. I have one question. So in one of your last slides, you were saying, well, there maybe we could introduce other modalities or maybe more realistic setups. How would you make the setups in the evaluation particularly more realistic? Is it more about introducing more partitions, like more clients, or is it more about introducing new data sets? What are your thoughts?
Yeah, so thanks for the question. Yeah, I think it's a good question. So we for the more realistic settings, I think it will come from two aspects. So first one is so just as you mentioned, the number of clients. I think the current setting is more like the cross silo setting. So that means the number of clients is not that high, but we can also do the cross device setting. That means we have more clients, but we also have a more strict resource requirements. Uh, so that will be one. And the other thing is the data distribution of the clients. So we can simulate somehow a more realistic setting, for example, to simulate the no ID setting, which will be yeah quite common in the real world.
Yeah, makes sense. And among these four, so there are four leaderboards, I think general NLP, medical, finance, and coding. Which of these modalities do you think has maybe the chances to have a much bigger impact? Or
Ever.
do you see one of them getting people more excited from your interactions with the community?
Well, I think yeah, I'm not sure which one will be get better impact, but I hope every challenge will to get like a more attractive for different type of groups. It's quite separate topics, and the people doing that maybe from the specific domain, and they are only interested in the specific topics that they are working on. So hopefully, yeah, every challenge could get more attraction. Yeah.
And for you, which one is the most interesting?
Most interesting.
For you, yeah.
To me, I think the medical and the finance one to me is more interesting because the data type is quite I say it's realistic settings when people in these domains really has this demand to do the federated LM fine tuning. So yeah.
Yeah, I agree. I think those two are quite important ones. Okay, amazing. Well, Jan, thank you very much for your presentation, and thank you also for everyone that was included as an author on the paper or that made us addition to the Flower LLM leaderboard.